Okay, today we're going over 5.4, which is graphing polynomial functions. We're going to start with just some of the characteristics. So the first thing is that the graphs are continuous, which means they're smooth with no breaks. The next thing we're going to talk about is that leading coefficient. The leading coefficient is the number in front of the highest power of x. If that is positive, then the graph is going to open up to the right. So that means this: as the x's are getting bigger, remember f of x is just another name for y, so are the y's. I'm going to draw a quick example of that right here. So if my leading coefficient was positive, whatever point was like over here on the right, the graph would be going up. And then the other one says, if your leading coefficient is less than 0, or if it's negative, then the graph will go down. So again, this is all dealing with the right. So that's the right side of the graph. This is the left side. This is the right side. And then the last little characteristic we're going to go over right now is the degree n. The degree is the same thing as the power. The highest power of x. And whatever the highest power of x, so for example, this one is 3, the number of turns the graph will take will always be that number minus 1. That's the maximum number of turns. So when I'm looking at the powers of x in part B, I'm looking for the degree, which is that power right there. So this one right here, the max number of turns is going to be 3 minus 1, because here's the 3. We learned up here it has n minus 1 turns, so that one has 2. And then for right end behavior, I always want you guys to make this little plus minus chart. As the x's are going to positive infinity, we're going to look at this leading coefficient right here, which is 1/2. Is that positive or negative? That's positive. So the graph is also going to go up. Then we would say it would go to infinity, because it's going to go up forever. Let's look at the next one. The highest power of x is 2, so the maximum number of possible turns is 2 minus 1. Now for the right end behavior, I keep telling you guys to do this plus or minus. This right here is negative 1, so we're looking at 1/2 on this guy, but the number in front of the highest power of x here is negative 1. And that's negative, so guess what the graph is going to do? It's going to go down forever. So we're going to write negative infinity. Now when we get to the next example, so what you're going to do is we need this first term. And this is in factored form versus being multiplied out or expanded form. What we're going to do is we're going to take the first term in each one and multiply. So x times x times x times x. So that would be x to the 4th. And then if we had to multiply that out, that would be really annoying. But thankfully for these questions right here, we only need to know the first term, which we would find by multiplying the first terms all together. So we're good. This is the 4. So our max number of turns is 3. And then for our right end behavior, we're just going to look at this number in front right there. That's a positive 1, so this graph is going to go up, so we're going to write infinity. Now this one right here, we need to write it in expanded form rather than in factored form. So we're going to take the negative and multiply it by x and another x. So that's negative x squared. And we know that there's a whole bunch of other stuff after this. We only need that first term. So max number of turns is 2 minus 1. So right end behavior, we're going to see that that's a negative 1. So it's a minus. So this graph to the right would be negative infinity. Now we're going to move on to figure out what it does to the left. If the highest power is even, the right end behavior and the left end behavior do the same thing. So they match. What happens when the highest power is odd? They do opposite of each other. So now we're talking about the left. But in order to find the left, we have to know what it's doing to the right. So that's why we have all this stuff up here. Identify the left and right end behaviors of the graphs. Right end behavior is always plus minus. This is the leading coefficient, so that's negative 2, which is negative. So to the right, this is going down. Now for left end behavior, it's even odd. We're looking at that number right there. So 3 is an odd number. And it's nice that actually is an O, because we know if it's odd, then we do the opposite. So this graph would be doing the opposite and going to positive infinity. But I'll just show you kind of what we're getting to. To the right, the very most x-intercept will go down, and to the left, it'll go up. There'll be something in between here, but for now we're practicing how to find what it does as it's getting bigger and bigger. Right end behavior here, plus minus. This is the number in front. It's the coefficient, so that's positive 1. So this is going to go to infinity. And then the left end behavior, we look at even and odd at that number. So that's 4, which is an even number, and if they have the even, they match. This one was infinity, so its match is also infinity. So what this graph would look like is the right and left would both be going up, and it probably does something like this in between, but something like that. Now we're going to go over 2 more things. They are intercepts. So the y-intercept is when x equals 0. When you want to find your x-intercepts, these are also called zeros, the y equals 0. Another way to say that is just y equals 0. Multiplicity is the number of times each factor appears. If I had this function, so these are factors, we have a factor of x minus 1, and its multiplicity is 2 because it shows up twice. X plus 1 factor has a multiplicity of 1 because it just shows up one time. If the multiplicity is even, like this guy, then the graph bumps the x-axis there. If the multiplicity is odd, it's just going to cross through. So I'm going to type this in. X minus 1. You don't have to do this, just watch. Okay, so it's into the calculator and I hit graph. So if you look right here, this is -2, which corresponds to this intercept. So right there, that only showed up once. So do you see how it crosses right through? Versus x minus 1, which is that right there, and it comes down and it doesn't cross through, it turns around. That's called a bump. If the multiplicity is even, it's going to bump, and if it's odd, it's going to cross through. First, for this one, find our first term. So x times x equals x cubed plus a bunch of other stuff. For right end behavior, that's plus minus. Left end behavior is even odd. This is a 1, so that's positive, so it's going to infinity. This is a 3, which is an odd number, and odd is opposite. So this is going to be negative infinity. X-intercepts, y equals 0. We're going to take that, which we know is another name for y, is we take each factor and set it equal to 0. And then we solve it. So our first x-intercept is 3. So on a graph, that would be 3, 0, which is right there. Our second x-intercept is -2. That's there. And then our third x-intercept is going to be 1. Now for the y-intercept, your x-coordinate is 0. So this is what we do. We plug in 0 because this says here's the x and it's going to be 0. So we get 0 minus 3 times 0 plus 2 times 0 minus 1. That's -3, 2, and -1, which is going to be +6. So this is going to be the x is 0, the y is 6. Well, right end behavior is infinity. So go to your dot that's furthest to the right. That's this guy. And almost draw a straight up arrow. And then this is left end behavior. So we go to the leftmost point and we go down. And then remember, this graph can take 2 turns and it's crossing through on all of these. So in order for it to connect with a smooth curve, it's going to have to do that right there. These look intense, but once you get the hang of it and break it down, it will be easier for you. So step 1, I get this, and it says right end behavior, which means I need the first term So I'm going to multiply all these together. So this is x to the fourth. Right end behavior, plus minus, left end behavior, even odd. The number in front is the 1, which is positive. So to the right, once I find that point, this graph is going up. This number right here, 4, is even. So it's going to matchy-matchy. So O is opposite and E is exactly the same. To find our x-intercepts, we set the function equal to 0, or y. So the first one is x equals 0. The next one is x minus 3 equals 0. Then x plus 3 equals 0. Then x plus 2 equals 0. Add 3 to both sides. So that's going to be 3, 0. Subtract 3 on this guy. And then subtract 2. Okay, so I'm just going to plot all these points. 3, 0, negative 2, 0, negative 3, 0. And then we need to find the y-intercept, which means that we plug in 0. So then we go 0 times 0 minus 3 times 0 plus 3 times 0 plus 2. And just in case, I'm just plugging it up into this equation because that's the one we're working with. So I get 0 times negative 3 times 3 times 2. 0 times anything is 0. What are we doing to the right? We're going up. What are we doing to the left? It's matchy-matchy. So remember, these guys cross through everywhere. So you can kind of see it's going to have to do that in order to get through and make a smooth graph. The next one is the last one where we're fully graphing. We do have to make a B right here because right away I want to remember I see that as a bump. So if you see a square or a cube on one of the factors, then you should write it all the way out. Instead of writing it as 1, write it as 2. Because here we have negative 1 times x times x times x times x, which is negative x to the fourth. So that negative in front does get counted in this. So we have plus, minus, even, odd. So the number in front is negative 1, which means that's negative. So this is going to go to negative infinity. And then this right here is a 4, which is an even number, which means it's exactly the same as the right. So that's negative infinity. Find our x-intercept. Like we said before, this is really 0 or a negative 1 right there. And you're going to set each piece equal to 0. Each factor. So I get 0 equals negative 1. That's false, so we're not even needing to look at it. So I get x equals 2, and then that's the same thing. So I'm going to put a b there to remind myself to bump. Then I have negative 1 and negative 3. Okay, so I have 2, 0, negative 1, 0, negative 3, 0, and then I'm going to do f of 0. Keep using that equation right here. 0 minus 2 is negative 2, 0 minus 2 is negative 2, 0 plus 1 is 1, 0 plus 3 is 3. So I have 1, 2, 3 negatives. So I know this is going to be negative. 2 times 2 is 4, times 1 is 4, times 3 is 12. So this is negative 10, so that is 0, negative 12 down there. Okay, where is that bump? It's going to happen right there. I'm going to put a B there, right at 2. So it is falling to the right, it's falling to the left, so it just turns around there. But these guys cross through, so that's what the graph looks like. So again, the bump is like it comes up, touches, and then turn around, versus like the turnaround point is the x-axis. Is it crossed through first, then turned around, then crossed through again.